Hey, I'm Dominic St-Pierre, and you're listening to Go Podcast. Today we'll tell the story about how Go's concurrency saved my .NET performance problem. Hello Gophers, episode 13. Let's start with a quick news about Go 1.20. There's something that caught my attention regarding the errors. There will be a way to join error and unwrap a slice of error. So basically there will be a new join function in the errors package, and that would give a way to unwrap multiple error at the same time. So very interesting addition. Sometimes it gets complicated when you have multiple level of error, and now the unwrap would extract each error one by one. So I think it will be nice. So it will be coming in 1.20. So check it out if you haven't seen it. I will have some link in the show notes, by the way. Other than that, things are going well, and I wanted to talk a little bit today about concurrency, because my last episode was kind of saying that it's not the selling point of Go. Well, it is not, but it's still very important, and it was funny that I was kind of saved by Go's concurrency in the last couple of weeks. So I will tell this story today about that. So this story starts with me having to generate a lots of, let's call this a magic number for a lots of entity. I cannot go into too much detail about what it is exactly. Suffice to say that there's a process. I'm doing consulting, and we are in .NET world. For some reason, I still do some consulting with old client of mine in .NET, but that's not the point. So imagine that there is something in .NET that take an input and does a lots of SQL queries and a lots of small algorithm and things like that to calculate something at the end, which is a score. And so it takes about, I would say, around 7 to let's say 7 to 15 seconds per entity to calculate. So I needed to calculate that for around 300,000 entity. So that doing that synchronously one by one was out of the question. And I tried to do that with the .NET for parallel for each, but it was painfully slow. So I was starting to be a little bit afraid that the database would not be able to sustain the load and things like that. So, and at some point I decided, well, Go would be a nice candidate to spread the load with its concurrency. At least I would have more control over what's going on concurrently versus the parallel for each of .NET, which I'm not even sure what it was doing. Was it even doing anything in parallel, or it's certainly not concurrently? It's not the same thing at all. So I decided to start and investigate. Well, how would Go help in that situation? How could I call a C# a .NET function from Go? So I decided to extract this functionality in a very, very quick and dirty web API call. So I said, well, Go would be fine, calling multiple HTTP requests concurrently, and I would at least have a way to start calculating, what would be the threshold of that. And at least I would know what's going on, because I would be the one building this concurrent code or way to call those requests. So if it's the database that is the bottleneck, I would know exactly, and I could adjust how many concurrent job or worker I have. So that was the start of my solution with Go, and it was just after releasing this last episode where I was saying, well, concurrency is not the selling point of Go, and I'm myself going to use it to solve my problem. I forgot to mention that it's not only 300,000, it's 300,000 times 24, because it needs to generate that number for the last 24 months for each entity. So that was like roughly around somewhere 6 million things. So 6 million times 5 seconds was like 5 days of running, of runtime. It was not at all acceptable. So what I did is I started to look, which of the concurrent pattern would fit the bill, and I think I've already sold a little bit. It was the worker pattern, the work queue, where I knew that I don't need this response at all. I just need Go to dispatch a lots of concurrent web requests, and they don't even need to do something. I don't need to do anything with the response. There's no response at all. There's only a 200 HTTP OK if everything is fine, and that's all I'm going to track. So I said, that seems pretty easy, implementing the work queue pattern for the concurrency is extremely easy. So that I started with doing I created a struct where I have a queue channel in there, and this channel is of type int, because my entity are represented by int. So that is basically an ID on the database. So that's all I needed to do. So from there, I needed a way to create multiple Go routine that will take the next int from this queue channel whenever they are done doing the previous one. So I created a simple function that basically loop over a maximum worker. This is a constant that I decided to create, because I did not really knew exactly what was the number. So I said, okay, let's have a constant there, because it will be easier to fine tune. So I have a for loop that loop over how many concurrent worker I want, and inside that there's just a Go routine that will do a for and grab the next item in the queue channel. It's very, very easy, and inside this when there is a value in the channel, I'm just going to call a function, which is, like you might imagine, just at the end of the day calling an HTTP request with this ID. That's it. I mean, pretty crazy the amount of code I needed to write. It was very, very tiny. Less than less than 100 line of codes, and probably less than 80. I don't remember. That's not very important for now. So I have this function, and this is basically the core of the worker queue concurrent pattern. Basically, it's just a loop that will loop the amount of worker you want, and inside there you have a Go routine that just wait for the next item in a channel. I created another function to add this add some int into that channel, right? So that's basically what it is going to do. So we have a function that accepts a hint and just write that to the channel. So one of our worker will be able to grab it at some point. And from there, it's just a matter of grabbing your initial list. So in my case, it was 300,000 int, for example, and just looping over that and calling this add function, which will add the new int to the channel. The important part to remember with this worker queue pattern is that you need to start your worker before adding, of course, because otherwise you will not be able to add, since the channel are blocking until someone is grabbing this item that you are trying to add to a channel. So by design, channel are blocking. When you add something to a channel, you need someone to take that out before you can send something new, unless you have a buffered channel. But I did not want to do that. So pretty simple. Let me recap quickly. So we have our function that start our workers. We have a way to add new values into a channel, and we have a way to, in a loop, to just add all those items. I ended up using the sync.wait group to wait for all of those to be completed. So each time I was after grabbing all my 300,000, I just added this number, and every time an HTTP request was completed, I was tagging that one with the work group done function, and pretty much that was it. And at first, I was not really knowing exactly how many workers I was needing, and it's pretty hard at first when you are building concurrent application, to understand. Well, will it be that fast? I mean, it cannot really be. So I put an arbitrary number of 500 workers, and I took the web server down. I mean, it was not a good. It appears to be kind of crazy how many. And it's not the first time I will say that, but .NET is the old .NET, right? It's not .NET Core, but the old .NET was kind of not really scalable, and it was kind of bare minimum what you were getting out of the core library, if you will. So I dropped down to 100 concurrent worker, and it took around 2 hours 45 minutes or something to generate all of them. So yes, a pretty nice solution. Go save my it saved my day with this this .NET problem that I was having. And the simplicity of the concurrency was extremely appreciated. So I was in charge of everything. It took probably less. I would say less than 4 hours to write the entire thing, test everything, and run that in production. So yes, I mean it was kind of epic. All right, that's it for this week. I hope you liked the episode. And again, if you can share and talk about the podcast, that would be extremely appreciated. Also, if you want to check my book out, I have a course named Build SaaS App in Go. So it's at buildsasappingo.com. All right, see you in 2 weeks. Bye.